the way proof systems work, and ZK starts in particular, is you ask the prover to take a computation, let's say running for 1 million steps, add a lot of redundancy to that computation by using an error correcting code, committing to this more elaborate data, and then answering a very small set of local random questions. And the math shows that if the statement was true, all of these questions will be answered in a satisfactory way. Whereas if this was a lie, with 99% probability, some inconsistency will be exposed. So I'm saying that I ran a computation, for 1 billion steps and reached a certain result. And you would like to devise a way for it to be very easy to ask me a bunch of small questions about the nature of the computation that I did and see whether I'm speaking the truth or not. Okay, so you want all of this redundancy added to the steps that I took. The analog of all of these external factors that I should experience as I'm walking around in the physical world, let's say traveling outside of the country. Now, the way we do this in a computation is we ask the prover who is making the statement to create, this redundancy and have all of this extra information arise. And the way this extra information is arised is by adding redundancy in the form of what's known as an error correcting code. So instead of just stating or recording the steps of the computation, let's suppose that there were 1 million steps in the computation. I was updating the state of some system by doing 1 million small steps. Now what I'm going to do as the prover is, first of all, I'm going to do those 1 million steps and then add another 100 million steps to just add a lot of redundancy via what's called an error correcting code. And now I have this much more elaborate statement with a lot of interconnections between different parts of this bigger statement. And what I'm going to do with it is I'm going to submit it to some court. I'm going to take, put it inside an envelope, commit to it in a way that I cannot change it, and say, here is my deposition, right? This is not just the computation that I did. This is a lot of redundancy added on top of the computation. And then what happens is, because of this redundancy, when I am asked to answer a few samplery questions about connections between the various parts of my computation, it will magically be the case that if my computation was correct and my statement was correct and my end result was correct, I will always be able to answer, in a satisfactory way, all questions I am asked about. The analog of what was the weather, what is the sum of these two parts, what was written in this cell at this time, what was written in that cell times whatever, what was written 5 cells later, and all kinds of questions like that. I will be able to open up and show that my answers to all of these questions were correct. Whereas if I'm trying to cheat and I'm trying to prove a statement that is actually false, then there will be a lot of local inconsistencies. The analog of saying, oh, the weather was hot, but actually, 2 questions later, I will be saying that I wore, a coat on that day. It was raining, and things like that.